Hello, Yushman. Yeah, good job. Hey, Matt. Hello. Matt, by the way, New York has announced the first Zig Day. There's a Zig Day Stockholm. There's a Zig Day Seattle. There's a Zig Day Kitchener Waterloo, which has announced the first event. Fuck, I should have put that also in the announcements. That's October 18th. Yeah. Let's see. Yeah, no worries. Hey, Cyberfart. Buonasera. Cool. Okay, let's see. Gotta go. Have a nice day, Matt. Also, have a nice day, Ayushman. Hello, Type Lambda. Hello, hello. Hello, everybody. Okay, so what's the plan for today? The plan for today is, well, first of all, I'm a little bit late because I've been busy setting up a bunch of new stuff for Zig Day. By the way, we are like, we're starting to have a respectable number of events. This is not bad. This also is interesting because it shows how the USA is way more proactive with this stuff than like Europe, but still we have something in Europe as well. There's also a new one that we might get soon. That, well, I started talks with a potential organizer. They just need to basically give me a banner image and a description before I publish their stuff. But that's gonna be in Serbia, I think. So yeah, so not bad at all. Okay, what's the plan for today? So no more Zig days. The plan for today is this. Um, the plan is that github.com, Christoph IT, Super HTML. So we have an issue, an APR to look at, but I'm gonna delay doing that. I have a currently active fuzzing crash that I need to diagnose, and then we should fuzz more, and then we should keep fuzzing, fuzz all the things. That's the idea, right? So, yep. Okay, so here's the repro. So this is the input. And if we try to run it through Super HTML, we get a crash. So, yep, what's happening here? We don't know. And we have to figure it out, basically. So here's the plan in practice. Work AFK 10 minutes. Pause all the things. Why did I also put a WQ in there? Okay, we want to fuzz all the things. I need to make myself some tea. Drink some tea, and then we start. And we need to figure out what the heck is it that we're doing wrong in here. We're doing something wrong somewhere. We just need to figure out what it is. Yep. So I'll be right back. Hello, I'm back. Okay. Whew. It's time to do some fuzzing. Let's make it happen. Too late. You're a chair now, Diablo. So here's what's happening. We are in the tokenizer, and for some reason, our index is like almost 100 characters past the end of our slice. So, like, what happened? What is what the heck? So here's what I think is going on. I think we have somewhere a actually, you know what? I don't even know. This is genuinely puzzling. The crash is in the tokenizer. This is the input, but we know one thing. This is not the first parse. This is us. This is us reparsing attributes in element.zig. We are in element.zig and we are reparsing attributes. So here's what we can do. Let's plop this in LLDB. Run. Let's go up a bunch. So this is where we crash. I wish I could print source. Problem is it's not gonna work. Like if I do print source. Oh. Well, actually, it does print something vaguely reasonable. The problem is, well, you see, it's not. It doesn't understand slices. I fucking hate that LDB doesn't understand slices. Anyway, so let's go up. How do we get in here? We were inside a VAIT. Why are we inside of a VAIT? Because we're doing attribute global index. That's not exactly correct, because so what's happening here is that if we are inside the VAIT, then we are inside VAIT.next. Like this is an iterator. Yeah, a VAIT is a validating iterator. It's an attribute iterator. That it's an iterator for the start tag of an element. I wish there was one in here. I only see doc types and oh, there we go. So it's an iterator that gives you attributes in a start tag, but also it also does the duplication. So if it sees duplicate attributes, it generates an error for the duplicate attribute, and it doesn't propose it to you twice. So if we got in there, oh, you know what? I think the fact that here we do nothing on parse error, it's kind of sus. Oh, I think I know what it might be. No, never mind. That's actually okay. So this is where I fix this. So never mind. The fuck? So we do while next, maybe after. Okay, so here's what we can do, actually. Here we can print the end index, which is 1078. This is where this slice ends. 1078, which makes sense. That tracks. But our index is much, much further away. How the heck? Okay, let's go up. The question is, yeah, what are we looking at even? So what is print e? E dot tag I. We're inside of a I element. We're inside of a I element. Do we see an I element? There's an li. There's a base down here. There's capital I. Oh. Where's this? I see nav here. Fifth line from bottom. Thank you. Oh, this one. And this one. I guess this is an opening tag with garbage. This is a closing tag with garbage. Delightful. Let's see if we can reduce this. Yep, I think we correctly reduced it. So yep. Oh wait. Yep, okay, we reduced it. Also, why did we change that it's causing this? Okay, let's rebuild. I think here the debug info went out of sync with the executable, so that's why. Well, the source code went out of sync with the debug info because it's pointing at a comment. Oh, where's the main? Oh shit. Right. Git switch. I forgot. Fuzz. We need to go in fuzz 016, and now we can build. There we go. There we go. Okay, we're hitting an else unreachable. There we fucking go. We're hitting an else unreachable. That doesn't explain how the fuck did we get out of sync with the other thing, but okay. You know what? I think we want both versions of this. I think we want both versions. Oh shit, this wrote everything in fuzz1. Okay, I'll take it. Zig debug symbols external to binary. Yes, that's how it works on macOS. In macOS, you never have debug symbols in the binary. They always exist somewhere else. And the way that stuff works is turbo funky. Really turbo funky. Okay, so we're hitting the unreachable. 858, I know what that is, and that sucks. So here's what I'm doing. We are starting a validating iterator because we were reported that a tag exists. But it seems that in this case, that the tag that we were reported, the tokenizer reported a tag for which we can't even identify a tag name. So this is what's going on. Basically what's going on, I'm going to add some prints. So std debug.print. Talk. I'm going to call it, wait, what is it? T, and then we do, actually maybe we can do any and just print the full token. Yeah, let's just print the full token. Why not? Okay, so let me do this. And now, watch this inside here. Actually, let me use Zig1. So, here's what's happening. Let's print also something that says that we're starting. Okay. Oh, right. There's not a lot going on. Just want to make sure. So, we see a parse error, unexpected solidus in tag because of this. Wait, then we see a name. Oh no, then we see an attribute. Then we see a parse error. Okay, so here's the problem. Why are we not getting the I? We are, so here's the failure. The failure is that we are failing to report the I. I wonder if this could be reduced even further. Like if it was just this, would we still crash? Yes, we do still crash. Maybe it's a Unicode. It doesn't matter. Even if that were the case, I can tell you precisely what the problem is. The problem is that we have the tokenizer can run in two modes. One mode is a mode that only returns element names. Sorry, it only returns elements and I think also element names. Well, it doesn't return you attributes. It does parse attributes, but it doesn't return them as tokens. Because when we do the first pass, in a sense, when we build the AST the first time, we don't analyze attributes. Or rather, we don't store attributes in some kind of linked, in some kind of like a slice. We retokenize them every time we need them. And so there's a second mode in which the tokenizer returns you attributes. And I think what's happening is that in the second mode, this combination of errors causes the tokenizer to fail returning a tag name attribute. It immediately a tag name token. It immediately it only reports parse errors, and that's fine. But then it also goes to attributes right away. So we need to see what this code path is, because normally this is not what you will see normally, even if the presence of a parse error. So let me change this briefly so that we can see any normal way. You will see something like this. Normally you will see the syntax error. Man, this works a little bit well. We don't even see the VAIT. Let me make this a valid, potentially valid element. Yeah. So you see the start tokenizer returns a tag name. Is it because it needs to be, wait, is it because it needs to be connected for it to be an unexpected solidus? Huh. Oh, look, this is enough to trigger this. Basically, we get unexpected solidus in tag, but we don't get the token, the attribute name. We forget that there's an attribute name. There's a case then basically when this happens and we need to return that, but we fail. Okay, so this is a much more well-behaved example. So I'm gonna use this. So tokenizer. There's only one place where we return unexpected solidus in tags, so it has to be here. And basically, we are saying reconsume in the before attribute name state. So here we are not returning the name. Oh no, I think I get it though. Before attribute name state. It says reconsume. Well, what if you say a solidus? Reconsume in the after attribute name state. It is kind of weird. Okay, I think in any case that here what we're missing is literally the code to so this should be the third. And here there should be a name. I guess assuming there is a name. So I guess how did we get here? Self closing start tag. Why did we get in self closing start tag? Okay, I need to start from a state that I know what the meaning of it is, and then move from there. So let me see. There's tag name. Tag open. Create a new start tag token. Set the tag name to the empty stream, reconsuming the tag name state. So there's a tag name state. So if we see alpha, which is here, okay, tag name state. There we go. So we see the character, and then we see the solidus, and we say switch to the self-closing start tag state. I think this is it. This is the problem. Here, this is where we should say, wait. if it's return attributes, we should return the attribute. SCD debug assert tag name len greater than 0. Why do we know that that is always going to be the case for sure? Well, I guess because if we got into here, it's because we saw at least one character. So we can do this basically. Yeah, look, tag name end. And then we go into self-closing start tag. Why is it the reason? Is the reason that we don't return this because we do it in here sometimes? So we need to also double check this because we might return the tag name like twice by mistake. So if we are in return address mode, tag name, so perfect. So these all seems perfect. We need to double check what happens in here. Oh, this is the one that I was modifying myself. Okay, let's see. Yeah, no, in EOF, we just produce an error, closing tag. Oh, wait a second. So if you see a greater than sign, if return utters and tag utter count is 0, so this returns an error. Otherwise, the token is tag. The fuck is a tag token? There's tag name. What's a tag? Only return when return utters is true. Return during normal operation. Oh, right. So tag is something contains span, name, utter count. Okay. Okay. But then why would we do this under return others? Hmm. Hmm. I think so. I think that we have a bug in here. This whole thing is a little bit buggy. So the question is, we see the closing diamond bracket. What do we do? Well, what we want to do is, I guess at this point we don't do this. If utter count is 0, if return address and utter count is 0, so I guess this is, if you are at the end of the tag and there was no attribute, then we return the full tag. And then the token is tag name. But we shouldn't have to do this because we can return the tag name earlier. I think what happened at some point is that I noticed that in some circumstances we were not returning the tag name. But this is, we can return a tag name always before transitioning to this state, I would say. So I would say that this is completely unnecessary. And then the question is whether it's either this or that. So something like this. Or you know what? Yeah. Okay, now we need to, I think we need to double check all the transitions to this state and guarantee that all of them return the name if they have to. So let's take a look at them. Where are we right now? Tag name. So we're looking at the tag name and we are transitioning to self-closing start tag because we see a solidus, but here we do return the tag name. So that is what I just fixed. So we're happy. What is going on here? We are in row text and tag name. Jesus. Okay. Is appropriate. I'm going to ignore this for now. Let's see the next one. After attribute name. Okay, we're after an attribute name. And we see a self-closing start tag. And we say, sorry, we see a slash. And so we say, okay, let's transition state. And we return the token first. Yeah, I think after attribute value. So if we are after attribute value, my assumption is that we have already returned the value. So there's nothing for us to return here. Hello, X2. Self-closing start tag. That's the thing itself. Okay, so I think that with this, we have fixed our bug because now we will correctly return the name in both modes. And now it doesn't crash anymore. Let's return to this. Now it works. And also, you know what? I bet you that I can also do this now. Here, I can also, this comment is not true anymore, and I can YOLO pull it. And I bet you that I can go back to YOLOing it. Okay, let's write pass one with all the extra stuff. Perfect. We don't crash anymore. So we fix this. Oh, there's a debug assert, which is fine. Oh, I made a get a comment for it. Oh well. You can probably fix the function to a singular return state. No, I can't because of side effects. So this mutates the inner iterator. And so I have to do it on a copy of it. Then I'm going to copy out because then otherwise I'm going to lose this side effect. So it's fine. Okay, so we fixed another fuzzer crash, another crash that was found by the fuzzer. So congrats. Now, the next step is obviously to, well, fuzz some more and see what happens. So far, we found 7 crashes with designated fuzzer, and we fixed all of them. And again, for such a simple piece of software, this is amazing. Oh shit, that's a change that I made. Really, this doesn't work. Expected type size found vector. Oh, so that's why it is what it is. Okay, never mind. That's on me. That's on me. I made a change that I shouldn't have made. Sorry. That's on me. Okay, so who knows? Let's leave it fuzzing for a bit. So this last crash, it took the fuzzer a while, like 30, maybe 40 seconds for it to find it. So it might take a moment. Let's leave it fuzzing for a while. And if we don't find anything, then the next thing that we can do is fuzz more stuff. Right now, we're just fuzzing the parser. I think we should start fuzzing also the formatter. Right now, we're just not doing it. And also in the coverage, you can see how much of it. By the way, these numbers are printed wrong. This is not a 0.2%. This is a number that goes from 0 to 1. So this is 20%. This is 10%. But still, there is a lot of lines that we don't hit. And also, hitting those lines might depend on state. So it's not like hitting all of them once is going to be enough to have explored the full state space of the program. But still, it would be nice. But as you can see, it's not easy for it to make progress. Like after a while, here you can see that it is going up. It is covering new code paths bit by bit. But the first 1900 takes a moment to, it doesn't take much, 1800 maybe, it doesn't take much to explore. But then the remaining ones are a little bit more pesky. They're lower probability, and so it takes us a while to get into those. But still, we're getting there. Hey Andrew. Oh yeah, I found 7 different crashes with this. But you have to be clear. Here's a key point. This fuzzer is leveraging a generator, right? That is important. Like I have my generator that can generate these interesting examples for the parser to kind of bypass the tokenizer, roughly speaking. In order to avoid generating random crap that always stops at the tokenizer and never gets to go past the tokenizer. So that helps a lot. So yeah, basically right now, let me put it this way. Right now, this fuzzer would still be, this fuzzing process that I'm doing would still be somewhat decent, even if I just hooked up a random number generator to this, to the program that generates this stuff. Because it would generate them completely at random, but it would probably hit interesting stuff. This fuzzer right now is not super great at knowing what is interesting input versus not. This is kind of like the key defining characteristic, in a sense, between a fuzzer and just using a random number generator. The fuzzer should be able to prioritize which previous inputs to mutate based on information about code coverage. And right now, this fuzzer is not too sophisticated with that. But it's still, let's just say that it's, in any case, sophisticated enough to actually work. So, yeah. Whoops. Okay. So the fuzzer is not finding anything. So I think we might want, maybe I'll leave it there running in the background. But in the meantime, I guess we want to start working on these other things. So here's what we have. Here's what we're missing. We're missing all the area dash something attributes. Probably we need those. Duplicate name detection and duplicate ID detection. Those are probably also nice to have. Maybe it's worth start using it slowly. Yeah, I actually want to. I'm waiting for Andrew to. He's been away for the last few days. I'm waiting for him to return and see what he thinks the next step should be, because I kind of want to start working on it. What changed yesterday was 300 runs per second. Um, Good question. Honestly, I don't know what changed. I don't think that anything changed. I think it's just trying shorter input right now. I think that for one reason or another, the last time it was just generating very long inputs, and now it's sticking to shorter ones. But look at how hard is it for it to make progress from here, though. To be honest, this should be. I think a better fuzzer would be able to make progress here better. Still, it is making progress, so I guess that's better than nothing. Although, you know what we can do? So, okay, here's the other thing I can do. I forgot about it. I said that I would do it and I forgot. Let's go to AST. Let's go to the fuzz test. And here's what we do. Once we do the AST, then we try to we try to render it. So we try to do ast.render, and render takes in source, which we totally do have. Where is it though? It's out.written, and we need a writer, but I think writer dot discarding. There we go. Discarding dot init. Wait, is this not what I think it is? Discarding writer. I'm confused. Why does a discarding writer need all this stuff? I'm surprised that it has like state and stuff, but okay. Okay, let's see how this goes. Okay, we need to do the check ourselves because it's a certain one. Okay. Please explain what is built in debug in the web interface. Compile test debug native. Compile exe release safe native. Oh shit. Have I been testing a debug? Also, holy crap, there we go. We immediately found a crash in the fuzzer. Sorry, in the formatter. Well, congrats. Oh, this is it. Well, no, actually, this is it, right? I mean, okay, so this is another input that causes stuff to crash. Oh, this is fuzz one now. No. Huh. Wait, what is going on? I think I might have taken the wrong input then. Index out of bounds, index 57, length 57. Oh, maybe it's because I added a white space that shouldn't be there. Oh, it's because my editor adds a new line at the end. Fuck, how do you tell the editor to not add a final new line? Nah, copy from the terminal won't get the exact same bytes from a failed sample. That is true, but also weirdo non-UTF-8 symbols don't really affect. They don't really affect um, a crash, I think. So okay, I don't know why I'm having trouble reproing this. I'm sure we'll be able to repro it again. So what was the other problem that I was encountering? Oh yeah, that apparently, yeah. So there was this question from Olvilock about what's being built in the bug, and I was saying, wait, nothing should be built in the bug, and then there was something built in the bug, And I think this is because in setup test step, look at this. We don't pass target, optimize, which is bad. And we should pass optimize so you can run tests. Here. So you can run tests as you want. Although we do have Super HTML, but does Super HTML has target, it doesn't have optimize. Why does it not have optimize? So if we pass optimize to Super HTML, then we should be fine, I think. Let me see. Anyway, very, very good find. This might actually make a gigantic difference, a ginormous difference in our ability to fuzz. Because if we haven't been building tests in LSP code gen debug native, so this one is fine. This one is fine. Yeah, it doesn't matter. Yeah, there we go. Compile test release save native. There we fucking go. Hell yeah. Now watch it. Yeah, watch it speed run crashes now. Oh man, why did we not see? Why did we not see the rest of this thing? Did we not flush something that we should have flushed? This is a debug print. Also, the fact that this is a debug print is bad. Let's make this better. Yeah, I could copy the repro from the temp files. The problem is that those are a mess and they're not really reliable. Also, guess what? Guess what? So you see this guy. This needs to be piped into zig out /bin/generator. And of course, it contains a buttload of new lines. Plus, God knows what this thing did to my to my terminal. /super HTML fmt dash. So far, you see, this one is not it. One thing that I noticed is that the files on disk are not reliable. This is one of the bugs in the current fuzzer implementation. So yeah, no, we need to print them. We really need to print them. Let's make this print more efficient so that we can also fuzz faster, basically. So how does this work? Although, you know what, making it buffer doesn't matter much. Yeah, actually making it buffer doesn't matter much. It's just a couple prints. It's just 2 prints, basically. So that's fine. But I'm surprised that this somehow failed. I'm surprised that it failed midway, basically. Like, we see this. Do we need to add, like, more new lines? Because basically the Zig printing is like eating into the output for some reason. Oh, also, you know why those things are weird, I think. Yeah, why do we see this? And then it like somehow seems that it fails mid-print. That makes no sense. That really makes no sense. And I bet you that this is not... Also, this is incomplete. We know that it's incomplete because this should be lorem ipsum. And it's not. That is really weird. Really, really, really weird. Okay, let's do the non-release safe version. Is the faster running instances in parallel? No, not yet. It only does one process. Okay. So maybe we did get it. Is this it? Let's see. No. Also, where did we crash? Is white space. Okay, index out of bounds, line 57. Okay, this is again a... And an end of line thing, I think. Maybe I should open a memory mapped file and keep writing to it. Do basically what the fuzzer is doing just on my end. 52, not 57. Yeah, but these guys, they are probably a bunch of different code points, different code points that with, or whatever those things are. Maybe they're not even good code points. They're probably more than 1 byte each. So you saw that all these arrows are going out of whack, and that's because of the malformed data. You know, we could also add UTF-8 validation and say this is not valid UTF-8. Okay, so what was I looking into? Oh, what was I looking into? Oh, wait, does it do this? Oh, check this out. That is actually cool. You see the progress go while Zin is open. And also same afterwards because I control C and reset doesn't clear that. Clear obviously also doesn't do that. Wait. How do you get rid of this? Oh shit. Oh, it dies after a while. Interesting. Okay, so what do we do here? I guess we can diagnose this even if we don't have a repro on hand. We can at least take a look and I mean, it's clear that this could very well be the case. Current open.end. Yeah. This could totally be the EOF. So, am I enjoying Ghosty? Yeah. 1.2, definitely. So, yeah, let's do some manual assessment. AST 1064. I mean, yeah, current open.end could totally be past the end. So, Open was vertical. Okay, what is the question that we're asking here? We're asking if the open tag was vertical. While we're printing while we're exiting, I see. Was that the OSC 94 progress bar? Yes. That was it. Although that is like the I don't know how much progress I'm making mode. There's also a mode where you do know the progress that you're making. Like when I run Zig build, this part, it doesn't know because it's building the build script, but then it knows. Although it's not great at showing progress because everything is fast except the LLVM step. But let's say that we had like a complex build process, like with a ton of sub steps, then they would show up nicely. Because that will only know how to fix that if it goes ahead on term info. I see. Okay. So what's happening? I want just to double check. I understand how to fix this like mechanically, like just how to avoid going past the end of the string. The question is, what are we doing semantically? Like, are we doing something that is legitimate semantically, and then that also should inform how to do the fix. So here we are rendering an element, and we are deciding. Oh, and we are doing the enter exit thing. So if we are exiting, that it means that we are looking at the element that is not self-closing. Oh, I see. The element is not self-closing, but it could very well have a missing closing tag. So basically, the whole string is just an open tag. It ends there where the open tag ends. And then here we're saying, well, is there white space afterwards to decide what to do next? But here's what we can do. If if we are at the very end of this, we don't need to print any of this. There we go. Yeah. So this should fix it. Unfortunately, I had trouble reproing, but the bug seems obvious and the fix seems reasonable. Let's see how many. I'm curious to see how many iterations we do per second now with this new system. The problem is that we crash way too fucking fast now. Jesus. Wait, is this repeating this thing for some reason? It does seem to be repeating this. But no, that is really sus what we're looking at. I don't think that this is our repro. Might be wrong, but I don't think that is it. Oh, never mind. You know what? I take it back. I think we killed the LSP. Or not. Quest 7 timed out. Also, I need to rebuild the executable. Yeah, no, this is not it. Okay, you know what? Let's do this for a moment. Let's turn off the Let's turn off this. Just momentarily. Just momentarily so we can see how fast it goes in actual release safe build. There is a pretty serious performance difference between debug and release. So let's see. And hopefully the new speed should allow us to make progress faster. So I expect that also to be interesting. Bro. Oh. Well. Well, Mr. Mlog, huh? Well. Okay, I'm in a branch from Mlog where he I mean, he added this code to support loading debug info, and that's, I guess, a case that he didn't implement. But why are we hitting this now, though? This is actually really weird. This was working like up until a second ago. We did build unit tests in release safe, and we did fuzz them. I just commented out some code. What is going on? I'm building now the debug version now to see what's happening. So this is fine. But release safe is not fine. Wait. But this is fine? You know what? I think that basically this crash that we're seeing is not a... These are not real crashes right now. This is the fuzzer having trouble loading debug info in this case. This is it. The problem is that so the fact that we were seeing these instant crashes in this mode is because of that. Okay, so I guess that's fine. Let's keep fuzzing the HTML the formatter and see what happens. That's sad though, because fuzzing in that mode would be good. There we go. We found another crash in the formatter very freaking fast. Start index 146 is larger than end index 0. Really. So this is it. See if this works. We're having real trouble reproing these thingies. That sucks. Let's do it this way. Okay, I think this is better, just visually for me. So we're having trouble repping. Also, wait, is this fuzzer? Oh, you know what might be? Wait a second. Let me double check how FMT works. Oh, shit. Did I program it bad? Format file. Fuck. Fuck. Here's why I couldn't repro. It's because we're not actually performing the format from the CLI tool if there are errors. But that's not how it should work. How it should work is that if there are errors, we print them, and then if ast.has syntax errors, we SCD process one. Otherwise, we print alloc print we alloc print. Why do we alloc print? I guess format HTML needs to return something more. Yeah, we have to tell people what's going on. And this is out bytes. And this is result. You know what? Let's give it a struct that has like errors. Okay. Bytes and errors. So we get result, and here we do result.bytes. Then what? Check bool. If check print full path return. Okay. Atomic file. Finish. So this, what is it? This is format file. The problem is that this could have happened in a. We need to return basically if there was any error. Okay. FNT super also needs to do the same basically. It's weird to me that FMT HTML does exit one on some errors. I was fine in the past. Before it was fine, but now we need to make this more fancy. Previously, in the past, the presence of any error would immediately cause us to refuse to format. Now, I'm more sophisticated, and I know that some errors I'm distinguishing between errors that make formatting an unsafe operation. Syntax error makes formatting an unsafe operation. You don't know if what you're doing makes sense. But there are other higher level errors like, duplicate attribute that absolutely does not prevent you from running the formatter. Of course, the formatter in that case will keep the duplicate attribute. It doesn't just nuke one of the two. But yeah. So, we're just making things more sophisticated as we implement more things. It's kind of natural. Do-do-do. So what was I doing? Format file returns a boolean about whether there were errors or not. So format file is invoked by this guy. Out bytes. No, this is result. Result of bytes. And then if result. I guess we can do std process.exit result int from bool result dot errors. If there were any errors, we return 1. Here, same thing. Paths is more complicated because it's multiple files now. So instead of dying midway, we now keep going. Although this maybe should be configurable. Like maybe there should be a way of saying, stop as soon as you encounter an error. But either way, yeah, we return if there were errors. Actually, here we do return because we don't. If check return for sure. What am I missing? Why does format HTML format file? Wait a second. Format file. Okay, format file calls format HTML or format super, right? And it does check for an early return. Okay, this is on standard out, isn't it? Yeah, this is on standard out, while here we print to standard error. Yep. Okay, FMT super. This is try. Okay, everything checks out. So the next thing that we need to do is go here and format dir, and format dir returns a bool. And it's var errors equals false. And here we keep doing this. Basically, we keep ORing errors with this. And then we return errors. Okay, and with this format dir tells us if there was any error. Oh, up here I had any error. Like what? Wait, what the fuck? Oh shit. I did have a way of communicating this. Well, you know what? We can take any error out at this point because we just don't use it. I see. We could have used any error as we were doing before, but I think this is also fine. This other way of doing it. But let's see where this takes us. So basically down here, we do this. Paths, multiple paths. We do var errors is false. And then we do format file. Just like this. That all works. And then, oh, you know what? We could even do this. Yeah, this works. Okay, hopefully we're doing everything right. This error I'm ignoring because this is it has to do with a different version of Zig versus what ZLS knows. Let's see, expected type, blah blah blah, return found void 133. Format file. Is this a return false? Wait, what is going on? We look at the file extension. If it's HTML, break with HTML. If it's super, if it is HTML, we break with .super. Otherwise, we return immediately. I guess that's fine. We weren't reporting an error before. We don't do it now. 151. Oh, if it's the same, we return result.errors. Funny question. Can a function have type error no return? Absolutely yes. Absolutely yes. A function that return error no return is a function that either returns with an error or it doesn't return. So you can totally have that. You can use that to represent a function, for example, that loops forever, but that has try in it. So like it loops forever in the happy path, but then it could at some point error out. Or you can use that for a function that can either return an error that you can handle and do stuff with it, or that on success calls exit. You can also use that to model that. Running such a function? Yes, indeed, it is. Well, it was, right. It was already, and for sure, yeah, we could do this. And actually, maybe you know what's nice about this is that now that we communicate this information to the type system, if somewhere else above in the main function that calls into this one, I am doing some cleanup, I now know that this cleanup will never happen because I always call this one. Also, this one is no return, right? Yes. So we call into no return. So we know we are communicating this to the type system. Let's see if that gets us some nice compile error now. Okay, what is the problem? 151. Did they fix that one? Yeah. Oh, also this. Okay. Expected type bool found void 43. Wait, expected bool found void 43. Location is slightly wrong. Format does return. Format does return stuff. What am I missing? I'm starting to regret not having the Boolean pointer around. I guess there's a branch where we are not returning a Boolean. Basically, we're calling format there. So here we're doing this. Here we're catching the error. Oh, right. And if we catch the error and we call into this, or in general, if we enter the switch, then what do we do? So these guys are no return. So this is fine. This is no return. This is no return. But here what happens? The answer is that we basically want to continue. We don't want the assignment to exist. Yeah, maybe that other Boolean pointer wasn't all that bad, huh? Wasn't it? Was it? So how do we fix this? We're missing basically continue. I guess in here we can do here we do continue. Let's see if that appeases the build system. Sorry, the type system. Expected, found, no return. There we go. Now we got the type error in CLI. So what is the problem? What was it? Line 83. Right, so check it out. Here I'm catching errors. I'm calling fatal. I have a defer args free in here that doesn't really happen, I guess. You know what? I'm taking it out because it's misleading. Okay, I see. Basically now I made this one no return, but the other ones are still void. Is this one really no return? This one is also no return. This one does not exit. This one is void. So this one we can make no return. But we do need to make it no return for real. LSP. LSP is generally no return, I think. We have a deferred here. Yeah, but I don't think we ever return from it. Or that we even care, to be honest. So... Oh, you know what? I'm actually wrong. What I was saying about CLI, that we don't do this ever. No, we do that in case of error. So that's fine. Process exit 0. Now we made that one no return. This one is no return for sure. This one is no return. Okay, let's see. Let's see how we're doing with the type system. Oh no. Function declare implicitly returns. Fuck, in check. In check. What a traitor. This is fine. It implicitly returns. Wait, what? Oh yeah, down here. Um yeah, okay. Okay, let's see. Oh, there we go. Now we can finally repro because now we will attempt to format even if there are higher level errors. Okay, we're now able to repro our crashes. So the problem was that I was using a different command. A command that had different semantics. Yeah, I could do that. That's whatever. It's good enough for now. So AST 1048, huh? Print interface as HTML. No, what the fuck am I doing? AST, HTML AST. There we go. 1048. So what's happening here? Start index is 148 and index is 0. We are saying that the last right bracket is after the current closing tag. After the start of the current closing tag. What? Oh. What? That is bonkers. That is absolutely bonkers. So, what's causing this? And this is inside PRE. Okay, so this is an example where we are inside PRE, right? Oh, what? Holy shit! Look, it's not even that complicated. Like we are like turbo fucking it up. Holy cow! Right. What's the input? Let me see the input. Yeah, like we are like mega giga turbo fucking it up because it's not like it's so complicated the PRE. So okay, give me a second. I'll go to the bathroom real quick, and then we need to understand what the heck is going on. Oh, actually, maybe I know. Wait. Oh yes, current close start. Guess what? Current close start assumes that the current tag, which I'm guessing is the PRE, has a closing tag, except it doesn't have that. So, oh, right. I also know this. A close tag. Like, I'm calling close the end tag. So an end tag that starts at index 0 doesn't exist. This is when this is 0. That's what I used to say uninitialized. Or rather, it's not exactly uninitialized because I do set it to 0, but it means that this is an element that does not have a close tag. So we're basically failing to check to account for that possibility, which our fuzzer caught because it made a fucking self-closing PRE for some reason. But I mean that's what we paid to do. So I'll be right back, and then we're gonna fix this very quickly. Okay. To-do-to-do. Is the IO question? Can GPU IO be implemented using it stuff like CUDA memcopy? I actually genuinely do not know. I've never done GPU stuff, so I'm not sure. My understanding is that you usually have you kind of treat the GPU as like a separate system. So you have shaders, right? You have functions that are either like actual shaders or like computer shaders that you send to the GPU to run. And then yeah, I guess there has to be a way of maybe sharing memory or stuff like that in the ballpark. How would that integrate with IO? I don't think it would. Although I guess that some of these things are asynchronous, right? Some of the operations on the GPU are asynchronous with respect of the CPU, obviously. So you know what? I don't have a concrete answer because I don't have enough concrete experience. But considering the fact that the GPU and the CPU are asynchronous to one another, maybe some IO, maybe IO is something, it is an abstraction that could help with that. Yeah. Also, what the heck am I trying to do here? We are exiting an element and we are inside pre-RE. So we're saying, okay, show me the last right bracket. Oh, I see. The question is though, up until here, which normally would be close, but like, okay, so const span is if current dot self closing current dot open else current dot close. Wait. What am I even doing? If it's a self-closing tag, it means that there is no body. And if there is no body, there is no white space that we should worry about. Something like this. Oh, but we don't want to do this otherwise either. So I guess we don't want to do any of these things if the element is self-closing. Like if you're exiting a self-closing element, there's no white space in the body that we need to worry about. And actually, wait, what? Why are we not like bailing? Wait, why are we even? Wait a second. We are wait, yeah. I was saying wait. We are asserting actually that self-closing is false. You know what's happening? We are failing to write down that PRE element is self-closing. That is what's happening. We are failing to write down that element is self-closing. I think this is what's happening. Let's take a look at the init function for the AST. You see a start tag, HTML mode, increase SVG math level, whatever. Wait, where do we set the PED self-closing stuff in here? This gives us a new node, new parent index. Wait, are we seriously like never setting this property to new? We set the parent index, we append it, but when we create it, where do we set? Where? Okay, here, start self. Oh, this is it. Continue node with dot start. I think I understand what's going on. Okay, I think what is going on is that we need to set self-closing in all those other cases. We need to say self-closing is yeah, it's because we're on the start. Well, oh man, this thing that I did here really fucks up the logic. Jesus Christ. There we go. So with this, we can do this. We do it here. We do it here. We do it here. We do it here. I would even go here and pull into element tags. Fold into element tags. Maybe. I don't know. I'm not 100% convinced. Okay. The problem is that we were not writing down that that was a self-closing tag. Oh, there we go. 470. Nodes.append. Oh, this is the root node. I really should no, let's not consider it self-closing. Wait, what? Oh, I knew. There we go. Now we don't try to auto format. Like we don't forget that this PRE is self-closing. This was actually a pretty good fix. Oh, we can't do release safe, unfortunately. I think I should ask Mlog to fix that next. Already, man. Come on. Oh, shit. We got in here. Wait, we got again in here? Is it the same thing? 1057? Yep. Okay. Again, there is another element that we forgot to mark as self-closing. Oh, you know what? Well, no. Never mind. But yeah, there's another thing that we forgot to mark as self-closing. What is it? Well, there's a self-closing PRE. There's a self-closing article. What else is self-closing in here? Although, you know what? Wait, we are asserting that it's not text. Wait a second. So let me double check how this stuff works, actually. How do we select the next thing to do? Direction, enter, blah, blah, blah. Okay, so what do we do with the direction then, for example, on a doc type? On a doc type, we don't touch direction in this case. On a doc type, basically, we are asserting that we are only entering, we never exit. Okay, that makes sense. Like root, text, comment, and doc type. These are all elements that we render in specific manners. And then, yeah, we enter the next one. We're never going to exit a doc type, I hope. I guess we need some logs from here. There we go. Rendering exit address. Yep. So we're exiting address. The problem, though, is that, guess what? Oh, no, never mind. Wait, really? This is it? This is what causes it to poop itself? This? Just this? No. This plus what's after? No. Then I'm really confused now. footer, maybe? Oh, I've not been modifying it. So yeah, this is what causes it. So it's article. Wait. So it's with article that we have trouble. But I'm also curious, why are we doing... Why is this the last one that we print? Rendering exit 0. Element article. Rendering exit address. Oh, okay. So, okay. Address. We're trying to exit address, but there is no closing tag for address. Okay, so I guess this is just another version of the same bug. So what I did before wasn't actually the full solution. And we need to do better. So we could totally be exiting an element that doesn't have a closing tag. Yeah, and if in a self-closing element, that is normal and we shouldn't even be there, but you can totally be there for a non-self-closing element that just happens to, well, not have the closing tag. Yep. So where is this code? Here. We're exiting. Also, what is this stuff down here? Wait a second. I'm really confused. There's a while through where we switch direction. Oh, right. This is the... and then we do elements. Oh, shit. Okay, that makes sense. Okay. You know what, though? So this is the problem. The problem is an element without a closing tag is not something that we can format. And this is the problem. So I think that has syntax errors is not being updated as it should. That's a case where we are definitely generating a missing, like a you left this element open error, but we're not updating. Oh shit! Look at this down here. This is the one. It's the finalize 3 that for every element that it's still not closed, it complains. But guess what? We forgot to update this. Yeah, if there is a missing closing tag, we should not format. So yeah, so that code wasn't wrong. That code assumed a correct structure and it wasn't defensive against that. And it makes sense for it to not be defensive against that because, yeah, you just can't like, how do you auto format something where there's a missing closing tag? I guess you can if you want to, but the problem is that you're gonna mess up the user. So we shouldn't be doing that. This is the actual fix. The actual fix is correctly recognizing this. And by the way, we were already doing this in other cases. Like whenever we noticed that there was like an erroneous end tag, or whenever we noticed that, let's see what else is there, erroneous end tag, missing end tag. Whenever we noticed this elsewhere, we were already doing this. It's just that there was a location that wasn't updated. Okay. We might be running out of trivial crashes for our renderer. That's good. Format like self closing. That would be funny. No, I think that well, so the problem is that you could come up with heuristics on what to do if you really wanted to make it work. But the problem is that you risk destroying information that the user relies on. Maybe the user, is in the middle of doing something, of fixing it, and they just wanted to save the work in progress, and maybe they have indentation that is telling them where they are going to put the closing tag. Maybe they forgot, but the indentation is going to suggest that to them where is the right place, and now you destroyed that information by auto formatting. So that like missing a closing tag should count as a syntax error in that context. So we are not crashing anymore. It seems that we have given a reasonable like first fuzz pass to our renderer as well. Yep. Yeah, you can control Z, but the point is that you gave this service to the user. The fact that the user has to control Z it means that you did something they shouldn't have done, and and then on the other hand, which user would actually genuinely appreciate that the auto formatter kicked in the presence of a syntax error of that kind? I don't know. I don't think anybody would really appreciate that much. Well, it seems that we have done a good job. So here I have some interesting to dos to work on next, but I think I'm gonna stop here for today and leave them for tomorrow. I'm gonna wait a little bit more. I'm gonna give a little bit more time to the fuzzer to see if we can find something. I don't know if I should aim for a specific coverage number, but just a little bit more. What are you doing, man? I am fuzzing my HTML language server, discovering a ton of bugs and fixing them. And this has already been proven to be really good, really, really, really good. So there's that. I think we are almost ready for a release. I probably want to push in this one for sure. Also, you know what? We should also fuzz specific parsers. So we should create fuzzing tests that fuzz specific sub parsers. Absolutely. Okay. So we seem to be doing fine. Why is the speed going down? I think it's because input length is increasing. Like the fuzzer is producing longer inputs, and longer inputs take longer to process, and that's pulling down repro speed. That would be my guess. Okay. So yeah, only 98. No, this is not. This is printed wrong. This is not a percentage. This is a number from 0 to 1. Like, look at this. Is this number 0.1% of this one? It's not. It's 10%. So this is basically not a percentage that gets printed with a percentage symbol afterwards. So 10% of the runs are unique, and we are covering 20% of the program state, which kind of tracks. Is there any fuzzer that can discover every branch? Or what is the state of the art for fuzzer? Not familiar with this field. I don't know what is the exact state of the art for fuzzing. Can a fuzzer discover every branch? No. Fuzzers work on a statistically, so they don't they are unable to systematically discover every branch. You know, the way you discover every branch systematically is by, you start at 0 and then you go to 1, 2, 3. Like, you basically systematically run over all possible inputs. Either you do that, or you can do static analysis that can tell you what the edges are. Like, it can tell you where the interesting inputs are, but through static analysis. So fuzzing as a technique generally exists in a space where either you can't do static analysis, or like it's separate, right? So you can use them in conjunction. Like, you do static analysis on a thing, and then you can also fuzz it afterwards, and both can be good. But the fuzzer is in a sense antithetical to static analysis. So because of that, it can't really discover every branch. It can try stuff at random and see what sticks. It just throws a ton of things at the wall. Now, you can have dumber and smarter fuzzers, though. A dumb fuzzer is a fuzzer that has no understanding. I guess there are two dimensions, in my opinion, in which your fuzzer can be dumber or smarter. The one which is trivial but really important is speed. The way that the fuzzer integrates with your code is makes a gigantic difference. For example, if you use the most common fuzzer, one of the most common fuzzers is called AFL, AFL++ to be precise. And if you're using AFL, the simple way of integrating with your program is that AFL launches your program as a sub process, and that is really slow because you're basically creating an entire executable, like an entire process from scratch every time you want to run a test case. A better way is to basically have one executable that has an entry point controlled by the fuzzer, where the fuzzer can try inputs in a for loop. And that makes it much, much faster. So the number of runs that your fuzzer can do per second, that makes a huge difference. Then, so this is the first dimension. And in that dimension, this fuzzer is pretty decent because it doesn't do sub-processing. It runs test cases in a loop without having to fork a new process every single time. I guess related to this would be multi-threading, like or multiprocessing, as in basically being able to use multiple cores. And we don't do that. This is right now running in single-threaded mode, unfortunately. So we're hammering one core, but we are not really making full use of the computer. So AFL, for example, does have multi-threading support, so or multiprocessing, whichever the two it's using. And so if you use AFL, you will see all these CPUs to like using CPU 100% and making faster progress because of that. Second dimension is how good is the fuzzer at picking interesting inputs. So the way this works is through it's by having a code coverage guided fuzzer. So the way it works is that when you build your executable, you need to build it in a special way that adds that hides where the compiler inserts callbacks in specific points, and those callbacks basically call into the fuzzer, and that way the fuzzer becomes aware of whenever you're doing a comparison, whenever you're doing a switch, for example. And the fuzzer then can use that to know if a run was interesting or not. So for example, this is what distinguishes total runs from unique runs. We know all the program counters, like the addresses in memory where there's branching happening. And so we know that if a given input hits a code path, like hits one of those program counters, that wasn't hit before, then we have discovered a new state of the program for sure, compared to the previous input. So we made progress in a sense in terms of coverage. Coverage is not just hitting program counters, because program counters also, there's a state in the program that you should maybe account for as well. And so there's a bunch of techniques on how to do this. This fuzzer is not state of the art in any of these things. It has like the bare minimum stuff to kind of work. So it's not particularly smart at sniffing interesting inputs and mutating them. But it has the baseline to kind of work. So long story short, I think that reaching, if I was using 4,000 cores for 2 years, yeah. So I think that we can totally reach state of the art of fuzzers. And I think also because a lot of fuzzer research is, I think it's wasteful. Like I've seen some fuzzer implementation where there's like 10 bajillion different mutating functions for functions that like operations that mutate the input. And right now what we have is extremely bare bones. So I can show you the mutations that we have. By the way, these are the callbacks. These are the callbacks. Like we're comparing to bytes. We're comparing to U16s. We're comparing U32s. We're comparing U64s. We are entering a switch. To do the mutations. There we go. Mutate and run one. So here's our mutations. Remove a byte from the input. Modify a byte. Add a byte. To be fair, these operations alone are enough for maximum expressiveness. Like any possible input is possible to be generated through these 3 mutations. The problem is that you kind of want to have also a little bit more variety than this, probably. So that basically, how can I say? Well, let me put it this way. Let's imagine that instead of modify byte or remove byte or add byte, we had like remove bit, modify bit, and add bit. So instead of a byte at a time, we do it 1 bit at a time. We would still be able to generate any possible input for sure. But also imagine that you have a program where, for example, there's an if, and for you to enter with a given input, you enter one branch, like you go quote unquote left. So I don't know, like it's true. The if ends up in the true branch. But in obviously you want also to find an input that gets you into the else branch, possibly. So let's imagine that to do that, you need to, from the input that you have, you need to modify 10 bits at least. So that means that you need basically to have not just 10 edits. You need to have 10 sequential edits. You need to modify the first bit, of the 10 that gets you to the other one. And then you need to modify the second one, the third one, the fourth one, the fifth one. And randomly, you will eventually get there. But the problem is that every intermediate step, the fuzzer doesn't learn anything new, because for every intermediate step, you still keep going left. So you are making progress because given how I stated the problem, you are making progress towards getting to the else branch, but there is no way for the fuzzer to know. So having mutator functions that allow the fuzzer to make bigger jumps is a way of more quickly noticing, discovering that you did make progress. And then you also still want to have functions that only flip one bit potentially. So you still want to try out things like smaller minor mutations, even if they have lower chances of discovering new interesting states. So you still want to do that, but you also want to have the possibility of having bigger jumps, because with bigger jumps, the fuzzer notices new input, that something has changed, and then it can prioritize that. So it's not forced to, in the example that I made, where you need to flip 10 bits before you get to something good. There, like the thing is that the fuzzer doesn't, how can I say, it doesn't even always modify the same input. Like it tries the first input, then it creates a new input based on the first mutation, tries that one, but when it picks the next thing to do, it's not always based on the last input. It will also potentially jump back to previous inputs and modify an older one again. So doing the 10-bit step without any knowledge, without gaining any knowledge about the fact that you are making progress, it's really hard. It's kind of like a barrier. So you do want better mutations. That said, there is, I think, I think that what people are doing usually is a little bit too much. So for example, there's a PR that, by the way, have we found a crash? Haven't found a crash yet. Okay. There's a PR. What am I doing? It's author. Greatly improved capabilities of the fuzzer. So look at what Goon Creeper did here. Oh, of course, it's in the collapsed thing. Yeah, load diff. So Goon Creeper made a ton of changes, but I'm looking specific at the mutators stuff. We're getting there. There we go. Look at these. Delete byte, delete span, pop byte, pop span, move span, set existing span, insert existing span, push existing span, set RNG byte, set RNG span, insert RNG byte, insert RNG span. And I think the Goon Creeper copied all of these mutations directly from I forgot, man. What's this thing called? AFL, from AFL++. But man, I think there's a little bit too many. I really think this is overkill. So to answer, so my point, I guess, is that I think that state of the art is not necessarily bad, but it's not like super turbo sophisticated, at least not when it comes to mutations, and probably a limited subset of these is already good enough. And then the question is, how do we identify equal runs versus different runs? Like, how do we prioritize runs? Like, how do we like the function that kind of gives in quotes like a score to a run based on which machine code of the original program we hit, which instructions we hit, and maybe also something that analyzes state. And it's not easy. Also, it's really not easy because two runs could be slightly different but be basically the same. And if you count them for as different and interesting runs, then for example, this is the fact that here to do what is it? What am I doing here? The fact that here we consider only 10% of these runs interesting, unique, and not the other ones, it's because of a change that I made to the fuzzer. If you use the fuzzer right now from master branch, you will see that it will consider 100% of the runs interesting. And because of that, it will be much worse at making progress than this one because it will not know how to prioritize. It will not have a strict enough definition of unique. That said, the function that I'm using is probably not optimal either. So it may very well be that I don't realize that two runs that I consider to be copies are actually not copies, and they're actually different enough that we should try mutating more one of the two, for example. So I guess this is where all this stuff happens, and I do think we have a good shot at making something really good. But at its core, I think the main problem with fuzzing is that it's either the fuzzing is not properly instrumented, so it doesn't do multiprocessing, it doesn't integrate with your executable well enough, it doesn't have knowledge about the what's happening in the program, like the code coverage knowledge. By the way, also that can have varying degrees of quality. For example, AFL with LLVM 19 broke completely because LLVM 19 regressed some piece of instrumentation that AFL needed. And although to be fair, AFL depends on a piece of functionality of LLVM that is marked as deprecated. So long story short, AFL became much worse in your versions of LLVM. And I tried to reuse it. Like I tried to fix my setup so that I could use that for fuzzing Super HTML, but I couldn't because that whole thing like bit rot a bunch and it just wasn't working. And when it doesn't work, you don't know why it doesn't work. Like there's no like trivial path towards fixing it. So you can probably, it's just that it requires you to deal with C++ all over the place. So in that aspect, I think that the Zig fuzzer will be like totally state of the art. As for the mutations and prioritizations, that's going to be more complicated. But also, I think that the state of the art is not, again, it's not bad, but it's not probably super mega giga good either. So yeah, I think we can compete. Okay, so it seems that our fuzzer has, well, basically done what it could. And so I think this fuzzing adventure is done basically. So this is good. I'll ask Amlag if how hard is it to get the to get this working with release safe. By the way, the fact that we are running these, they were running tests in debug mode, this is actually really bad because it's making it harder for us to, it's slowing us down basically. Can you visualize coverage to check what is covered? Yeah, about that. So on paper, yes. In practice, if you click view, nothing shows up because it's bugged. But yes, we should. So there are actually two problems with this. This is bugged, like this piece of functionality is bugged, but also source locations generated by Zig apparently are not super precise. So you don't get the information that you wish you would get. unfortunately. So yeah, that sucks. But it's all fixable, of course. It's just this stuff takes time. But this is very promising. Man, once this stuff is gonna be good, oof, it's gonna be great. By the way, already in the current state, it has been helping me a lot. Like we found, I don't know, like 10 plus crashes by fuzzing. So yeah, this is very good. And by the way, guess what? Guess what we are not testing that we could be testing. But okay, just to show you, I think this is kind of important. So here is the fuzz test where originally I was just building an AST. Then I said, okay, I'm going to build an AST and then I'm going to try to render it if it's an AST that can be rendered and see if we hit another crash. And we did. And we did hit another crash. Some of which was also because we weren't correctly setting this variable all the time. So occasionally we would attempt to render something that we shouldn't attempt to render at all. Here's what's missing in here. For example, completions. Another thing that we could add to this to stress test the completions code is basically, and this doesn't even need the fuzzer. Here, what we could do is, okay, look at the input, and then we attempt to produce completions for every single position in the string, and we assert that while we don't poop ourselves as we do that, I have this feeling in my brain that we're gonna find crashes there as well, because I've never attempted to do completions, for example, at any possible index in a document. Completions, definitions, those kind of things. And we could totally test that stuff out as well. Yep. In any case, as I was saying, this is it. This is very promising though. This is gonna be very, very cool once it becomes more generally available for everybody. Thank you all for hanging out, and do try out Super HTML. By the way, these fixes that I'm making are currently in a branch, so I need to merge them back into main branch. But it's coming. So if you want to try out a good HTML editing experience, try out Super HTML. Let me know how it goes. If you find crashes, thank you for fuzzing the program for me. Yeah, I'll see you soon. Bye all. Actually, let me see. Raids? Anybody doing Zig? Oh, there's Ethernet cable doing Zig, so go say hi to Ethernet cable for me. See you all.